All right, hi folks. I'm recording a video for Section 7.5 that has to do with sum and difference formulas. Now, what that means is we are sometimes interested to analyze the sine or cosine or tangent of a sum of two angles. So let me give you an example here. Let's say we want to know the sine of, let's say, two angles. We'll call them alpha plus beta. Well, what I could do is use a formula right here. This is copied from the Section 7.6 part of our textbook. Notice I can rewrite it to be sine of alpha cosine beta plus cosine alpha sine beta. So what these formulas allow me to do is rewrite the cosine of the sum of two angles, or the sine of the sum, or the tangent of the sum. What if I have, though, the difference? Difference means subtraction. So what if I have cosine of alpha minus beta? Well, there's a corresponding formula I can apply in that scenario. All right, so these formulas are ways to rewrite the sine, cosine, tangent of either the sum of two angles or the subtraction of two angles. As we do some examples, we might also need this table that's taken from Section 6.1 on the unit circle. So we'll use this table as needed to look up values of sine, cosine, tangent for different angles. And notice the angles are given in both radians and degrees here. All right, let's go to this first example. It says find an expression that's equivalent to sine 50 degrees cosine 10 plus cosine 50 sine 10, times sine 10. Well, here's what I'm going to do. I'm going to take this expression they gave us, and I'm going to try to match it up to the right side of one of these sum and difference formulas. All right, well, I'm noticing in the middle of this expression is a plus sign. So my only options here, because it's a plus sign, will be either this formula, because that has a plus sign, or this formula. Okay, so I just want to carefully match up my example to one of these two options. But I'm noticing my example was sine and cosine in front. Well, this one is cosine, cosine, so that's not a match. So my example matches up to sine of alpha plus beta. And all I have to do is match up alpha and beta in my example. Well, this is sine alpha cosine beta here. So I could see my alpha is 50 and my beta is 10 in this example. So this is going to be sine of 50 because my alpha angle matched up to 50 and my beta angle matched up to 10. So this looks like it's just going to be sine 60 degrees. So it looks like the answer here is the fourth choice, sine 60 degrees. Okay? And the way I came to that conclusion is I took the expression they gave me and matched it up to the right side of one of these formulas. That allowed me to match up alpha beta. Then I could simplify, in this case, sine of parenthesis alpha plus beta. All right, let's do another example like this. Well, this one's asking me to kind of work backwards in the sense of taking a cosine of 105 degrees and trying to break it up into one of these possible expressions that they're giving me here in choices A, B, C, or D. Well, when I look at these choices, I'm noticing they seem to be breaking this up into the angle 60 and 45 degrees. So I want to be able to break this up to be cosine of 60 plus 45 degrees. But I'm noticing that really seems to match up to a cosine alpha plus beta kind of format. In my example, alpha is going to be 60 degrees and beta is going to be 45 degrees. Well, I'm going to go over here to my sum and difference formulas. I'm going to grab this formula for cosine alpha plus beta. So it says I want to write this as cosine alpha, cosine beta minus sine alpha, sine beta. But now I'm going to plug in the angles because I know alpha is 60 degrees. So this is going to be cosine 60 here. This is going to be sine 60 over here. Beta is 45, so I'm going to write this as cosine 45, and over here in the back, sine 45. Now I'm just going to match it up to one of the four choices and see which one of these match up. And it looks like answer D is the match to our expression. By the way, folks, this is one of the common applications for the sum and difference formula. Because when I go to figure this out, and if I wanted to use the unit circle, 105 degrees is not on the unit circle. But if I can rewrite 105 degrees as the sum of 60 plus 45 degrees, both 60 degrees and 45 degrees are on the unit circle. So every one of these quantities I could look up on the unit circle. I could use this table 3 to look those values up, and I'd be able to figure out cosine 105 degrees, even though 105 degrees is not an angle that's on the unit circle. All right, let's try another example. Oh, I'm sorry. Wait, we shouldn't leave so quickly because now they do actually want me to work out the exact value of cosine 105. All right, well, let's proceed then. So what they want me to do now is actually plug in values for cosine 60, cosine 45, and so on. So let's do that. Let me erase this, and we can finish this problem up. All right, so here's what I'm going to do. Let me go and look up cosine 60 degrees. And let me come over to this table. Here's 60 degrees. It looks like the cosine of 60 is 1/2. So this is 1/2. Let me look up cosine 45 degrees. Well, here's 45 degrees. The cosine looks like square root of 2 over 2. All right, let me go in the back. What about sine of 60 degrees? Looks like sine of 60 is square root of 3 over 2. And finally, sine of 45 degrees. Looks like it's square root of 2 over 2. Okay, let me simplify this because I can multiply through the parentheses here. Multiply the fractions together. So this is going to be the square root of 2 over 4 minus the square root of 6 over 4. And because these are two fractions with the same denominator, I'll keep the denominator the same and write this as square root of 2 minus square root of 6 all over 4. Okay. And notice it says simplify your answer including any radicals. So I'm just going to leave my answer as is because I can't simplify any radicals in this example. So let me enter this answer. I'll enter it as a fraction. So it's going to be the square root of 2 minus square root of 6 all over denominator 4. All right. Why don't we try another question like that? Let's go to number 4. And actually, I'm going to jump to another example. Let me jump to a different example. All right, let's take a look at this one. So this says find the exact value of this expression. All right, well, again, I'm noticing that what they're giving me here is a sine times a cosine plus a cosine times a sine. So I'm going to come over to the right-hand side and try to match up to one of these formulas. Well, I know there's a plus sign in the middle of this expression. So if there's a plus sign, I can only use this possibility or this possibility. But my expression is a sine times a cosine to begin with. So it looks like this is going to be sine of alpha plus beta. All right, so let me write this down here. They're giving a sine of 100 degrees cosine 80 plus cosine 100 sine 80. And I'm matching this up to sine alpha cosine beta plus cosine alpha sine beta. And I know that this formula is really based on sine of alpha plus beta. Well, I can see in my example, alpha matches up to 100 degrees and beta matches up to 80 degrees. So what I'm going to end up with then is sine of 100 plus 80, which of course is sine of 180 degrees. So when I compare answers here, it looks like the last choice is the correct answer for this one. All right, so again, this was an example where I matched up the expression they gave me to the right-hand side of these sum and difference formulas. All right, let me try maybe one more. Whoops, I left too early. All right, well, now they're asking us to actually come up with a value. Well, here is sine of 180. So they're really asking us to figure out what is the numeric value of sine of 180 degrees. Well, to help me out, let me do a little sketch here of the unit circle. Here's the unit circle, and I know 180 degrees would take me to this point on the unit circle. But that point I can write as -1, 0. And when I write this ordered pair on the unit circle, the x value is the cosine and the y value is the sine. So sine of 180 looks like it should be the answer 0 based on my unit circle analysis. So the answer to this question should be just a 0. All right, why don't we do one more example here. Let me clear the screen. All right, this is similar, but it's asking us to look at the expression that has a cosine and a cosine. And I'm also noticing it's a subtraction in the middle. Well, if it's a subtraction in the middle, then this is one possibility, and this is the other possibility. But notice my expression has a cosine and a cosine. Well, that only matches up to this example right here, which is cosine alpha plus beta. So let me write it. Cosine alpha plus beta, according to this identity, is cosine alpha cosine beta minus sine alpha sine beta. Let me write the expression they gave us underneath so we can match up the angles alpha and beta. So this is what they gave us. And what I'm seeing then is alpha matches up to 75 degrees and beta matches up to 15 degrees. So that means this is going to be cosine of 75 plus 15, which is cosine 90. And I think they're going to ask us, what is the numeric value of cosine 90? So let's figure that out while we're at it. I'm going to go to the unit circle again, because that will make this a little easier. I know 90 degrees is this angle right here. That's going to put us to this point on the unit circle. Well, that point is 0, 1 on the unit circle. But I know the cosine is the x value. So the cosine of 90 degrees looks like it's 0. All right, so I think we have what we need to answer this question. We figured out that this expression simplifies to cosine 75 plus 15. So that looks like answer A. And now they want us to actually work out a numeric value. We work this out to be the numeric value 0. All right, folks, hope this is helpful as you're working in the Section 7-6 homework.